morning. Welcome back. Today's lesson is on the distance formula and midpoint formula and circles. Let's review the Cartesian coordinate system first. Our Cartesian coordinate system has two axes. Your horizontal axis is your x-axis, and your vertical axis is the y-axis. The axes divide your coordinate system into four quadrants. Your first, second, third, and fourth. And they intersect at the ordered pair 0, 0, which is also called the origin. All of our ordered pairs are written XY. The distance between 2 points on a coordinate system is given by the formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. Now this formula in particular is a little bit tricky to remember, so we're going to talk about another way of finding distance between 2 points in a minute. But first, let's practice using the distance formula to find the distance between the points 3, -4 and 5, 4. We'll call 3, -4 x1, y1, and 5, 4 x2, y2. It doesn't make any difference which point you call which, just be consistent. So our distance is the square root of x2 minus x1, 5 minus 3, 5 minus 3 squared plus y2 minus y1, 4 minus -4 squared. We're going to simplify inside the parentheses first. 5 minus 3 is 2 squared plus 4 minus -4 is the same as 4 plus 4, or 8 squared. 2 squared is 4, plus 8 squared is 64. So our distance is equal to the square root of 68. To simplify this radical, we're looking for the largest perfect square that's a factor of 68, which is 4, and it's 4 times 17. The square root of 4 is 2 times the square root of 17 is our distance. If you recall the Pythagorean theorem, that's our a squared plus b squared equals c squared formula. Most of us remember this from middle school. We need to make sure we remember that this is for right triangles only. Now, the Pythagorean theorem is used to find missing lengths of a right triangle. The A and B represent the legs of the triangle. It doesn't matter which leg you call which, but C is always our hypotenuse, and it's the longest side opposite your right angle. So let's see how we can use the Pythagorean theorem to find distance. We want to find the distance between 4, -3 and 6, 4. The first thing you're going to do is plot those 2 points. 4, -3 is down here in our fourth quadrant. 6, 4 in our first quadrant. And what we're going to do is we're going to create a right triangle with those. So we're going to drop a vertical line here, a horizontal line here, and then the distance between those 2 points is represented by the hypotenuse of that right triangle. So now what we can do is we can label the sides of the triangle. This side is 2 units, where this side is 1, 2, 3, 4, 5, 6, 7 units long. And using the Pythagorean theorem, 2 squared plus 7 squared is equal to our distance squared. 4 plus 49 equals the distance squared, and 4 plus 49 is 53. To find the distance, we take the square root of both sides. And since 53 is a prime number, we won't be able to simplify this. So this is an alternative method to finding distance, and in fact, this is how we derive the distance formula that we saw in the previous slide. I don't have a preference with how you decide to find distance. In some cases, it's easier to use the Pythagorean theorem, and in other times, it's just better to use the formula. Verify that the triangle formed by the points is a right triangle. So we have our three vertices, -2, 5, 1, 3, and -1, 0. Before we can verify that it's a right triangle, in other words, how do we prove that it's a right triangle? We need to know some characteristics of right triangles. So the first thing that we know is that it satisfies the Pythagorean theorem. Also, we know that a right triangle has a right angle. And to form a right angle, we have to have two segments that are perpendicular to one another. Now, either of these options will work. The first option, using the Pythagorean theorem, requires that we use distance formula. We are going to have to find the lengths of all the sides. The second side only requires us to use slope. So we're actually going to investigate the second option of determining that two sides are perpendicular. So we're going to first graph our 3 points, -2, 5, 1, 3, and -1, 0. And we're going to draw our triangle here in red. Now, before we go any further, let's ask ourselves whether or not we think that this is a right triangle. A lot of times it's obvious that it's not a right triangle, and so there's no point in trying to verify it. But if we look at this, it kind of looks like a right triangle, maybe with that right angle being over here near that point, 1, 3. If we assume that this is our right angle, we need to prove that this segment AB, is perpendicular to segment BC. To do that, we need to find the slopes. How do we find the slope of segment AB? Well, we can use our slope formula, or we can use the graph that we have here and count the slope. To get from point A to point B, we had to go down 2 to the right 3. So that slope is -2 over 3. Now we want to find the slope of segment BC. And we can either go from B to C or from C to B. It doesn't make any difference. But we always use slope as rise over run. So to get from B to C, we go down 3 to the right 2. So we go down 3, to the left 2. To the left 2, which is denoted with that -2 in the denominator, which will simplify to +3 over 2. And if you recall perpendicular lines, the slopes are opposite reciprocals. So -2 over 3 and +3 over 2 are opposite reciprocals. So we know that AB is perpendicular to BC. Therefore, that's what this little symbol here means, the 3 dots. Therefore, triangle ABC is a right triangle. Now let's talk about midpoint. The midpoint is the middle. When we think about the middle, we think about averages maybe. And that's exactly how we find the midpoint. It's the average of your x coordinates and the average of your y coordinates. So our formula, the x value for our midpoint is x1 plus x2 divided by 2. The y coordinate, y1 plus y2 divided by 2. It's really important that you guys remember that this is simply finding averages, and that's why we add our two x values and we add our two y values. We know how to find averages. It's the sum of all your terms divided by the number of terms. Let's find the midpoint between 2, -3 and 4, 2. We're going to average our x values, so 2 plus 4 over 2, and average our y values, -3 plus 2 over 2. Simplifying this, we get 6 over 2, -1 over 2, and we can simplify our x-coordinate to 3, -1/2. A Little League baseball field is a square 60 feet on each side. Find the distance from home plate to second base. If you're not familiar with baseball, we have a diamond that's in the shape of a square, and they're telling us that each side is 60 feet. We want to know the distance between home plate and second base. Well, here's home plate, here's first base, here's second base, and here's third base. We want to find this distance right here. How are we going to do that? Since this is a square, that means we have a right angle right there, and we can use the Pythagorean theorem. 60 squared plus 60 squared equals our distance squared, using these two sides as our legs and D as our hypotenuse. That's the distance between home plate and second base. 60 squared is 3,600 plus 3,600 equals D squared. Adding those, 7,200 equals D squared, and we want to take the square root of both sides, and we're going to need to simplify this radical. The largest perfect square that's a factor of 7,200 is, in fact, 3,600 times 2, where the square root of 3,600 is 60 square root of 2. And this is measured in feet. Now let's talk about circles. We're going to look at the standard form of a circle only. When you get to pre-calc, you'll start looking at the general form of a circle, but until then, we're going to keep things pretty simple. The standard form of a circle is x minus h squared plus y minus k squared equals r squared, where the point HK is your center and r is the radius. The standard form of the circle makes it very easy to graph a circle because we can tell where the center is and then how far all of our points are going to be out from the center. I do want to note here that our standard form is x minus h, y minus k, and look at your center. Your center is at positive h, positive k. So we're going to look at how that minus sign changes the values of our center. Write the equation of a circle in standard form with a center of -3, 5 and a radius of 3. We're going to start by just plugging into our standard form. Here's your h, here's your k, here's your radius. So it's x minus h, which is -3 squared, plus y minus k squared equals your radius squared. Now let's simplify. X minus -3 is the same as x plus 3. Y minus 5 squared, and 3 squared is 9. So let's look at the difference. In here we've got x plus 3, where our center had an x-coordinate of -3. So generally speaking, when we're finding the center from the standard form, we're taking the opposite of these values. If it's plus 3, my x-coordinate is -3. If it's minus 5, my y-coordinate is positive 5. Now let's try graphing a circle in standard form. X minus 3 squared plus y plus 1 squared equals 3. I'm going to change this to 9. It's going to make things a little bit easier for ourselves. First, let's identify where our center is. Our center is going to be at 3, -1. And that's coming from our equation. X minus 3, since it's a negative, it's going to become positive in our center. Y plus 1, positive, becomes negative in our center. And now our radius is going to be the square root of 9, which is a nice pretty value of 3. I think that's what I intended in the first place. So we're going to start graphing by plotting our center, 3, -1. And now we want to plot 4 points. We're going to plot 1 point up, to the left, to the right, and 1 point down using our radius. If our radius is 3, we're going to start from our center, count 1, 2, 3 up, 1, 2, 3 to the left, 1, 2, 3 down, 1, 2, 3 to the right, and trying to connect these with the best possible circle by hand. That turned out pretty good. And there's your circle. Let's talk about what the domain of this function is. When I'm talking about domain, this is not a function. When I'm talking about domain, we're looking at the x values. Now, a good way to think about this is bounding the graph, which means enclosing it entirely between two values on the x-axis. If I look at this graph, I can bound this graph on the left and the right between 0 and 6. That marks our domain. Our domain is from 0 to 6. Now the range we're going to do the exact same way, but now we're bounding it from the top and the bottom. So if I look at this, I can bound this down here at -4 all the way up to +2. Be very careful when we're writing intervals. It's important to remember that we always start with the smaller value and go to the larger value. So the range is from -4 to +2. So just to review, we talked about our distance formula and our midpoint formula. Remember that with distance formula, we can also use the Pythagorean theorem to find the distance between 2 points. The midpoint formula, it's important to remember that we're just averaging our x values and averaging our y values. And that's why we add the x values and we add the y values instead of subtracting, which we've seen in so many other formulas. Then we talked about circles. We learned about the standard form of a circle, how to identify the center and the radius from that standard form, and then also how to graph from standard form. We'll see you next time.